Hi students, this is Mr. Yao. In this lesson, we are going to continue to learn more about how to divide radicals, or in other words, rationalizing the denominators. So in this lesson, the questions are going to be a bit more complicated. So before I actually talk about the details, let's look at example 1. Let's try to actually do something similar to what we did in the last lesson. In the last lesson, if we see a radical, we know we need to get rid of it by multiplying it a few times. So you see a square root of 6, maybe you're going to want to multiply the top and the bottom by a square root of 6. So you're thinking, oh, that's going to get rid of the square root of 6. So let's see what's going to happen. You're going to multiply the square root of 6 with the square root of 6. Yes, that's going to become just a 6. Then you're going to multiply the 5 and the square root of 6, which is going to be a 5 square root of 6. On the top, 4 times square root of 6 is a 4 square root of 6. So yes, the square root of 6 part in the front is gone, but the number on the back now becomes a radical. So you still have radical on the bottom of the fraction, which wouldn't work. So we need something a little bit different. And that's where we have a new definition called conjugate. A math conjugate is formed by changing the sign between two terms in a binomial. For example, x plus y and x minus y. They are conjugates. So you can see the x in the front stays, the y on the back stays. The only thing that changed would be the sign in the middle. That's how we define conjugates. The reason conjugates are important is they are factors of the difference of squares binomial. So when you have x squared minus y squared, well, that's x plus y and x minus y. And now maybe you haven't seen exactly why they're special, so let's have a look. This is what I just mentioned. X times y, x plus y and x minus y multiplied together is going to get you x squared minus y squared. And here another another example of conjugates. Let's say you have 2x plus 3. Then the conjugate would be 2x minus 3. We're not changing the front, not changing the back. Just the sign in the middle that is changing. So for example, another one, let's say you have 3 plus square root of 5. Well, then we would have 3 minus square root of 5. These are conjugates. The reason these are important is, well, if you actually look at the 3 plus square root of 5 and the 3 minus square root of 5, if we are going to multiply them, 3 minus square root of 5. So our goal to get rid of the radical is by squaring things, but we can't have extra parts that's going to remain there. So in this case, if we use conjugate, 3 times 3 is a 9, 3 times negative square root of 5 is a minus 3 square root of 5. Square root of 5 times a 3 is a positive 3 square root of 5. And lastly, the square root of 5 times square root of 5 is a negative 5. So as you can see, because they're conjugates, their parts are very similar, just the signs are different. The middle two terms are going to cancel. Then we are left with just a 9 in the front and a minus 5 on the end, which is going to become a 4. So in that case, we don't have the radicals anymore. That's why conjugates are going to be really helpful when we deal with more complicated radicals. Now let's have a look at example 1 again. 4 over square root of 6 plus 5. You can choose to treat the square root of 6 in the front and 5 on the back, or you can choose to switch them. 5 plus square root of 6. In this case, we are going to use the conjugates. We're going to multiply the top and the bottom by the conjugate, which is 5 minus square root of 6. Okay, let's multiply the top. 4 times 5 is 20. 4 times square root of 6 is a minus 4 square root of 6. And the whole thing on the bottom, we have 5 times 5, which is 25. 5 times negative square root of 6 is a minus 5 square root of 6. The square root of 6 times 5 on the top is positive 5 square root of 6. And then square root of 6 times negative square root of 6 is a minus square root of 36, which is a 6. So the middle two terms cancel out. We're left with 20 minus 4 square root of 6 on the top, and a 25 minus 6, which is a 19 on the bottom. In the previous lesson, we have mentioned about simplifying these fractions. One recommendation I have is to separate them into two fractions. So in this case, the first part is going to be 20 over 19, and the second part is going to be a minus 4 square root of 6 over 19. In this case, we can't simplify any of them, so that is going to be our final answer. That's example 1. Example 2. We're still going to multiply them by the conjugate, but this one you got to be careful with what the actual conjugate is. We have a -2 in the front. We do not change that sign. We're only changing the sign in between the two terms. So the -2 remains, and we have a minus square root of 3. Let's multiply. 5 times -2 is -10. 5 times the negative square root of 3 is a minus 5 square root of 3. On the bottom, -2 times -2 is a positive 4. -2 times negative square root of 3 is a positive 2 square root of 3. Square root of 3 times -2 is a minus 2 square root of 3. And square root of 3 times the negative square root of 3 is a minus 3. The middle two terms cancel out. We're left with a -10 minus 5 square root of 3 on the top. All over 4 minus 3 is a 1. So eventually the final answer is -10 minus 5 square root of 3. That's example 2. Moving on, example 3. Now we have 2 radicals on the bottom. Doesn't matter, we're still going to multiply it by its conjugate. The first number does not change. The second number does not change. We're just changing the middle sign since it was negative. Now it's going to become a positive. So it's also going to be a square root of 3 plus 2 square root of 5. Okay, let's multiply. -2 times square root of 3 is a -2 square root of 3. -2 times 2 square root of 5 is a minus 4 square root of 5. On the bottom, square root of 3 times square root of 3 is a 3. Square root of 3 times 2 square root of 5 is a positive 2 square root of 15. -2 times -2 square root of 5 times square root of 3 is a negative 2 square root of 15. And then we have the -2 times 2, which is a minus 4. And then the square root of 5 times square root of 5 is a 5. So it's the -4 times a 5. The middle two terms cancel. The -2 square root of 3 minus 4 square root of 5 on the top. On the bottom, it's a 3. And the minus 20 is a -17. Now we can actually separate them to simplify. The first part is going to be 2 square root of 3 over a -2 square root of 3 over -17. Simplifies to be 2 square root of 3 over 17. Second part, -4 square root of 5 over -17 is a positive 4 square root of 5 over 17. There you go. And that is our final answer for example 3. Moving on, example 4. In fact, everything it's about the same now, so you can actually pause here and try it. Now let's have a look. Multiply by the conjugate, which is 5 plus 2 square root of 7 on the top and the bottom. So now it's just you have more things to multiply on the top and the bottom. So square root of 2 times 5 is a 5 square root of 2. Square root of 2 times a 2 square root of 7 is a positive 2 square root of 14. -2 times 5 is a minus 10. And -2 times 2 square root of 7 is a minus 4 square root of 7. The bottom now. 5 times 5 is a 25. 5 times, 5 times 5 is a 25. 5 times 2 square root of 7 is a positive 10 square root of 7. Then the -2 square root of 7 times 5 is a minus 10 square root of 7. And lastly, the -2 square root of 7 times a positive 2 square root of 7. We got a minus 4 since the -2 times the positive 2. And then the square root of 7 times square root of 7 is an extra 7. Get rid of the middle. We are left with a 5 square root of 2 plus 2 square root of 14 minus 10 minus 4 square root of 7 on the top. The bottom, 25 minus 28, which is a -3. I can still choose to write them separately. -5 square root of 2 over 3 plus minus a 2 square root of 14 over 3. -10 over -3 is a positive 10 over 3. And lastly, -4 square root of 7 over -3 is a positive 4 square root of 7 over 3. That's example 4. Moving on, example 5. Still the same thing. Times the conjugate, square root of 2 plus 3 square root of 3. On the top, same thing, square root of 2 plus 3 square root of 3. Multiply, -5 square root of 10. Multiply, -15 square root of 15. On the bottom, square root of 2 times square root of 2 is a positive 2. Square root of 2 times 3 square root of 3 is a positive 3 square root of 6. The -3 square root of 3 times square root of 2 is a minus 3 square root of 6. And lastly, If you're always having trouble to multiply the bigger numbers, write them out. It's a negative 3 squared to 3 times a positive 3 squared to 3. Negative 3 times a positive 3 is a minus 9. The square root of 3 times square root of 3 is an extra 3. Get rid of the middle 2. I'm left with a negative 5 square root of 10 on the top, minus a 15 square root of 15 on the top, all over 2 minus 27 is a negative 25. So now I'm actually going to need to separate them and simplify. Negative 5 square root of 10 over negative 25. And then we have a minus 15 square root of 15 over negative 25. Clearly everything becomes positive. Positive. That's also positive. We can simplify the 5 and the 25. So the answer is square root of 10 over 5 plus 3 square root of 15 over 5. That is the final answer for example 5. Moving on, example 6. Same thing. Let's multiply with the conjugate. 4 square root of 2 plus 5 square root of 3. 4 square root of 2 plus 5 square root of 3. Things are just getting bigger. It's just a lot more multiplication. Top 4 times 4 square root of 2 is a 16 square root of 2. 4 times 5 square root of 3 is a 20 square root of 3. Negative 5 square root of 2 times a 4 square root of 2 is a negative 20 times 2. Just deal with the numbers in the front first together and then multiply the radicals. That's always the case, okay? Then we have a negative 5 square root of 2 times a 5 square root of 3. So it's minus 25. Square root of 2 times square root of 3 is a square root of 6. On the bottom, 4 square root of 2 times 4 square root of 2 is a 16 times the 2. 16 comes from the 4 times 4. Then the 2 comes from the square root of 2 times square root of 2. Then we have 4 square root of 2 times the 5 square root of 3, which is a 20 square root of 6. Then we're going to subtract a 20 square root of 6. Lastly, negative 5 square root of 3 times a positive 5 square root of 3. Negative 5 times positive 5 is a negative 25. Square root of 3 times square root of 3 is a 3. The middle two terms cancel. We are left with 16 square root of 2 plus 20 square root of 3 minus 40 minus 25 square root of 6. All over. That's a 32 in the front. This is a 75 on the back. And it's 32 minus 75, so we are left with a negative 43. Now we can choose to separate all the fractions. Negative 16 square root of 2 over 43 minus 20 square root of 3 over 43 plus 40 over 43. Lastly, plus 25 square root of 6 over 43. And that is our final answer for example 6. 2 more. I'll start you on 7 and 8, and I'll ask you to pause here and try them. So for 7, the only complicated thing is you have some radicals that should be simplified first. So this is going to be 3 minus 2 square root of 8. You can actually take out a pair of 2's from the 8. It's going to be a 4 square root of 2. On the top, square root of 24 could be simplified as 2 square root of 6. So now if I'm multiplying by the conjugates, I'm going to multiply with 3 plus 4 square root of 2 on the top and the bottom. So you can pause here and finish it. Okay, let's have a look. 2 square root of 6 times 3 is a 6 square root of 6. 2 square root of 6 times a 4 square root of 2 is a 8 square root of 6, and 2 is a square root of 12. But I can actually rewrite that is 16 square root of 3. There you go. On the bottom, 3 times 3 is a 9. 3 times the 4 square root of 2 is a positive 12 square root of 2. Negative 4 square root of 2 times 3 is a negative 12 square root of 2. Lastly, negative 4 times the 4 is a negative 16. Square root of 2 times square root of 2 is an extra 2 multiplied with a negative 16. Cancel things out. We're left with a 6 square root of 6 plus 16 square root of 3 on the top. On the bottom is a 9 minus 32, which is a negative 23. We can separate them. Negative 6 square root of 6 over 23 minus 16 square root of 3 over 23. That's example 7. Example 8. We're going to need to simplify the radicals first before we move forward. 27, you can take out a pair of 3, so making it a 9 square root of 3. Then the 8, you can take out a pair of 2, making it 4 square root of 2. As for the top, square root of 45, you can take out a pair of 3's, to make it a 3 square root of 5. The conjugate is going to be 9 square root of 3 plus 4 square root of 2 on the top and the bottom. Multiply, got 27 square root of 15. And then 12 square root of 10. As for the bottom, we have 9 square root of 3 times 9 square root of 3. Multiply the 9 together, which is 81. And then the square root of 3 times square root of 3 is just a 3. The middle, so 9 square root of 3 times the 4 square root of 2 is a 36 square root of 6. Then we're going to subtract, so these two now, 36 square root of 6. And lastly, negative 4 times 4 is a negative 16. Square root of 2 times square root of 2 is an extra 2. Cancel the middle two terms. We are left with a 27 square root of 15 plus 12 square root of 10 all over. 81 times 3 is a 243. And we're going to minus a 32, leaving us 211. We can separate the fractions, but you should already know that you can't simplify them. You can either leave it like that, or 27 square root of 15 over 211 plus 12 square root of 10 over 211. And that's example 8, and that is the second lesson for dividing radicals. Thank you.